Hey everyone, welcome back. Ready for another deep dive?
Always.
Awesome. Well, today we're tackling those massive elliptical galaxies, the ones shaped like giant cosmic footballs.
Right, right.
Totally different from our own spiral Milky Way. And for decades, their formation has been kind of a head scratcher for astronomers. But you sent me some research that suggests maybe we're on the verge of a major breakthrough thanks to the ALMA telescope.
Yeah, it's true. For a long time, we really struggled to explain how these massive elliptical galaxies formed. Like the old theories, they just couldn't quite account for how they got so incredibly big and round, especially so early in the universe's history.
Exactly. Because you'd think, right, if they formed gradually, kind of slowly gathering stars over time, that'd take way longer than the universe's early years would even allow for.
Yeah. That's the thing. It's like, how did they get so big so fast? And that's where this new research using LMA comes in. It's really exciting stuff. Because of its unique capabilities, being able to observe light from the very early universe, we're getting a much clearer picture of what was happening billions of years ago.
So what was LMA able to see that other telescopes couldn't? What's the big reveal about these elliptical galaxies?
Well, they observed over 100 distant star-forming galaxies. And what they found suggests that these massive ellipticals, they didn't form gradually at all. Instead, it seems they formed rapidly through, well, you could almost call them cosmic collisions, I guess,
Yeah.
between smaller galaxies.
Hold on. So instead of a slow, gradual accumulation of stars, it was more like a bunch of galaxies just smashing together. That sounds
Oh,
pretty intense.
oh, it was an incredibly dynamic period in the universe's evolution. Imagine, all these smaller galaxies, each with their own stars and gas, and they're colliding at incredible speeds.
Okay, I am now picturing like a cosmic demolition derby. But how did these crashes actually lead to the formation of giant elliptical galaxies?
Well, think about it this way. What happens when all that gas from those colliding galaxies gets funneled towards the center of the merger?
Yeah.
It's like a recipe for an incredible burst of star formation. We're talking about stars forming at rates 10 to 100 times faster than what we see in our own Milky Way today.
Wow. So these collisions basically created these giant cosmic nurseries, I guess you could call them, where just trillions of new stars were being born in a really short amount of time.
Exactly. And all of this was happening like 8 to 12 billion years ago, when galaxy collisions were much more common than they are today. It was a much wilder time in the universe's history compared to the relative calm we see now.
Yeah, I'm starting to understand why these elliptical galaxies have been such a puzzle for so long. I mean, if they were formed in these ancient epic events, it's no wonder they look so different from galaxies that formed more gradually. But how did the researchers actually confirm that these starbursts were happening? I mean, was it just a theory or?
Well, they used a new technique to analyze the light from these distant galaxies. And by mapping the distribution of that light, they were able to confirm that, yeah, there were these intense star-forming regions right at the hearts of these merging galaxies. It's like they were able to peer back in time and actually witness these cosmic fireworks firsthand.
So it wasn't just a theory, they had the evidence. They actually saw it happening. That's amazing.
It is, and it really raises so many interesting questions about the processes that actually shapes the early universe. We're really starting to see that galaxy formation is much more dynamic and dramatic than we previously thought.
This is all incredibly fascinating. But, I have to ask, what does this new understanding of elliptical galaxy formation, what does it mean for our understanding of galaxies in general? Could our own Milky Way have been shaped by, similar events in its past?
That's a great question, and it's one that, well, we're going to delve into that in the next part of our deep dive. The Milky Way might be a spiral galaxy today, but that doesn't necessarily mean it hasn't had its own share of cosmic encounters over, billions of years.
Okay, so stay tuned. We'll be right back after a short break to continue exploring the fascinating world of galaxy formation. Welcome back, everyone. We've been unpacking these amazing findings about how giant elliptical galaxies formed through these, epic collisions billions of years ago. I gotta say, it's really changed how I think about how dynamic the universe actually is.
Yeah, for sure. It's definitely a paradigm shift. And like you were saying before the break, this new understanding, it really has implications for how we view all galaxies, not just the elliptical ones, right?
Right, because we were just starting to wonder if our own Milky Way, a spiral galaxy, could have experienced, similar collisions in its past. It's kind of hard to believe considering how calm, how peaceful our galactic neighborhood seems today.
Well, yeah, I mean, Appearances can be deceiving. Even though the Milky Way is a spiral galaxy, there's actually quite a bit of evidence suggesting it's had, well, its fair share of encounters with other galaxies in the past, though maybe not on the same crazy scale as those that formed the giant ellipticals.
Okay, interesting. What kind of evidence are we talking about here? Like, are there signs of past collisions hidden within the Milky Way's structure?
Exactly. One really compelling piece of evidence is something called the Sagittarius Stream. It's this long, thin ribbon of stars that stretches across a huge portion of the sky, and astronomers believe it's basically the remnants of a dwarf galaxy that was torn apart and absorbed by the Milky Way billions of years ago.
Hold on. So even our seemingly peaceful Milky Way has a history of, like, galactic cannibalism. I mean, it's kind of humbling to think about our galaxy growing by, well, consuming smaller ones.
Yeah, it really is a reminder that galaxies are constantly evolving and interacting with their surroundings. The Milky Way might appear, serene and calm now, but its past was anything but quiet.
This makes me think about those upcoming observations we were talking about before, from those new telescopes like the James Webb Space Telescope and Euclid. You mentioned they'd be able to map the stellar components of galaxies in even greater detail. So how will that help us understand a galaxy's history?
Well, it's almost like cosmic archaeology. By studying the ages, compositions, and movements of individual stars within a galaxy, we can sort of piece together a timeline of its past mergers and interactions. Like each generation of stars, they carry clues about the conditions under which they formed.
So if we see a group of stars with a similar composition and age, but that are different from the surrounding stars, could that indicate they were born in a different galaxy that later merged with the Milky Way?
Yeah, exactly. That's precisely the kind of insight we can gain from these really detailed stellar maps. It's like we're looking for those subtle variations in what you could call the galactic DNA to kind of uncover its hidden history.
That's incredible. It seems like each galaxy has its own unique story to tell, a cosmic narrative kind of etched in its stars.
Yeah, it really is. And by
Yeah.
studying these individual stories, we can start to assemble, well, a more complete picture of galaxy formation and evolution as a whole. It's about connecting the dots between those ancient, epic collisions that formed those elliptical galaxies and the more subtle interactions that shaped galaxies like our own Milky Way.
It's all starting to come together, but I have to ask, if galactic mergers were so common in the early universe, and even our Milky Way shows signs of past collisions, is our galaxy, like, destined to experience another major merger sometime in the future?
You're right to bring that up, because actually, as we speak, the Milky Way is on a collision course with our nearest large galactic neighbor, the Andromeda Galaxy.
Wait a second, did you just say collision course? Like those two spiral galaxies, they're heading straight for each other.
It's true. They're hurtling towards each other at something like 250,000 miles per hour. And, well, current predictions suggest they're going to collide in about 4 billion years.
4 billion years. Well, that gives us some time to prepare. But seriously, what's going to happen when those two spiral galaxies finally meet? Will it be another one of those epic starbursts, those ones that formed the elliptical galaxies we talked about?
That's one of the most exciting questions astronomers are trying to answer right now. And it's something that, well, it's definitely something we're going to explore in a lot more detail in the final part of our deep dive. So buckle up. It's going to be a cosmic ride.
All right, we'll be right back after a quick break to continue this incredible journey through the universe and the future of our galaxy. Stay with us.
Welcome back, everybody. We've covered so much in this deep dive, from those ancient epic collisions that formed the elliptical galaxies to the evidence of past mergers, even in our own Milky Way. And now we're left with this image in our minds, right, of the Milky Way on a collision course with the Andromeda Galaxy. It's almost, I don't know, it's almost hard to imagine what'll happen when these two massive spiral galaxies actually meet.
It is definitely one of the most anticipated events, I guess you could say, in cosmic history. Even if it is billions of years away, right? It really challenges how we think about scale, and really highlights how dynamic the universe is.
Yeah. You mentioned that it's going to happen in about 4 billion years. I mean, it seems like a comfortably long time away. But, I mean, on a cosmic timescale, that's basically tomorrow. So what are astronomers predicting is going to happen during this galactic encounter? Well, the first thing to remember is that galaxies are mostly empty space. So when we talk about, the Milky Way and Andromeda colliding, it's not like two solid objects crashing into each other. It's more like a a complex gravitational dance, with
Yeah.
stars and gas clouds just kind of swirling and interacting.
Okay, so no need to worry about like our solar system getting sideswiped by a rogue star from Andromeda or anything.
No, no, no. The chances of individual stars actually colliding is incredibly slim. The real drama, that's going to unfold on a much grander scale. As the gravitational forces between the two galaxies, they start to distort their shapes, pulling and stretching those beautiful spiral arms that we see today.
Okay, I'm trying to picture. All right, you got these two grand spiral galaxies, their arms like intertwining as they approach each other, their stars swirling. I don't know, it sounds both beautiful and chaotic at the same time.
Yeah.
So what happens when they finally merge? What's that going to look like?
Well, as the Milky Way and Andromeda merge, their gas clouds, those are going to collide, which is going to trigger new waves of star formation. These bursts of star birth, they're going to illuminate the merging galaxies, creating a spectacle of, well, truly cosmic proportions.
Hold on, so we're talking about like another one of those epic starbursts, right? Like the ones that created elliptical galaxies. But this time it's happening right in our own cosmic neighborhood.
It is a fascinating parallel, yeah. While the Milky Way-Andromeda merger, it probably won't be quite as violent or as rapid as those collisions that form those giant ellipticals. It will fundamentally transform the structure of both galaxies.
Okay, but what about the supermassive black holes at the centers of both galaxies? What happens to them during the merger?
That's a question that has, well, I guess you could say captivated astronomers for years, right? We know that both the Milky Way and Andromeda, they harbor these supermassive black holes, millions of times more massive than our sun. And as the galaxies merge, those black holes are slowly going to spiral towards each other, drawn together by their immense gravitational pull.
Okay, so we've got colliding gas clouds, new stars being born, and supermassive black holes on a collision course. This is going to be one wild cosmic show. So what's the end result of all this going to be? Will the Milky Way and Andromeda just become like one of those giant elliptical galaxies that we were talking about earlier?
That's the most likely outcome, yeah. Over billions of years, the merged galaxy, it'll settle into a more stable configuration, likely resembling a giant elliptical galaxy. It'll lose its distinct spiral structure and kind of transform into a smoother, more rounded shape.
Wow. So the Milky Way, our galactic home with those iconic spiral arms, will eventually just become something entirely different. It's a reminder that even on a cosmic scale, I guess nothing stays the same forever, right?
It is a profound thought, isn't it? This whole deep dive, it's been a journey through cosmic time.
Yeah.
Exploring these dynamic processes that have shaped galaxies from the early universe to our own cosmic backyard. And I think it leaves us with this sense of awe and wonder at, the ever-changing nature of the cosmos.
It really has been an amazing journey. We've gone from the mysteries of those giant elliptical galaxies to contemplating the fate of our own Milky Way billions of years from now. Who knows what new discoveries are waiting for us in the years to come, right?
Exactly. With all these new telescopes and technologies, we're constantly pushing the boundaries of, what we understand, uncovering new secrets of the universe, refining our picture of how it all works. It's an exciting time.
Well, that brings us to the end of our deep dive for today. We hope you've enjoyed exploring the fascinating world of galaxy formation and all these incredible events that have shaped the universe we see today. And as always, keep looking up, keep asking questions, and keep exploring the wonders of the cosmos.
And until next time, remember, the universe is a vast and ever-changing place, full of surprises and endless possibilities for discovery.